Hey guys, this is the video for 24 and 25. I did this in class, but I'm gonna go over it again in case you missed it. So on 24 and 25, we have a question. I'm actually gonna start on number 25 because it's easier to see. We're writing out a rule. The tip of the cone is half the snow. So this is a question we wanna make sure we get right. So if we see this cone and the snow would be 160, right? Because 80 times 2. The tip of the cone, 80 is half of the snow, 160. We also know all the way around is 360. So that leaves 200 degrees of snow on the outside, which means the tip of this cone would be 100. This allows us to see a principle that happens not just sometimes in this question, but all the time. If you have a quadrilateral trapped inside of a circle, then opposite angles are supplementary, meaning they add up to 180. So our angle B and our angle D added up to 180 because their snow would add up to 360, and then if you go backwards, the half of each one of them would be 180, okay? So we could finish this question by saying this would also be 180 minus 85, which gives us 95, right? And what are they asking? Angle B, okay? So we have our answer, angle B. Now we're going to use that technique a couple different times on the front, which is why I kind of hopped back here. I'm going to go ahead and do this one though, just for speed, because each of these I think are ones we want to make sure we get right. All right, so this is 12 and that's 12. Tangent lines are congruent, right? This one would have to be 8 because this one is 8, right? And if this whole thing is 16, then 16 take away 12 is 4. This would have to be 4 because 4 plus 12 is 16. And then this would have to be 4. Now we have the information we need to add up the 3 sides. We've got this side, and this side, right? So the perimeter is the blue side, which would be 12 and 8, right? And the orange side, which is 12, 4 and 8. And the green side, which is 16, which we already knew that. So if we add these all up, we get our answer, 48. Cool. Okay, now looking at question number 3, it says the center of an inscribed circle. So what is my memory device? It says all of my children always bring in. So this reminds me that angle bisectors make incenters, and that's when a circle fits inside. So if I were to make a triangle and I wanted to find the incenter, I would cut each angle in half. So if I cut each angle in half, that's how I would find the incenter. So our question says, the center of the inscribed circle has been established. So they've done the angle bisectors. They've found the incenter. Now it said which point on one of the sides should be chosen to set the width of the compass. So if a circle is going to fit inside of here, something like this, right? Now, let's make that a little bit bigger here. So it should touch, right? The circle fits perfectly inside. Then what or how, rather, would this meet? This would be the radius, this would be the radius, and this is the radius. I need a perpendicular passing through that center that intersects with that side. That would be my radius. Okay? Now looking at the question number 4, and then we'll jump back to page 24. Which statement is valid for circumscribed circles? So we're going to finish our mnemonic device. All of my children always bring in peanut butter cookies. So perpendicular bisectors make circumcenters. Okay, so we need a triangle, and it says it's an obtuse triangle, so I'm just going to draw an obtuse triangle. And to find the circumcenter, I need to do perpendicular bisectors of each side. So we find the middle, right? We cut each side in half, and we cut each side in half at a 90. So make a 90-degree angle with the side, make a 90-degree angle with the side, and here I'm going to make a 90-degree angle with the side, and I didn't go perfect, but, you know, pretty close. Okay, so I found my circumcenter. And why is this circumcenter special? Well, it's kind of like our radio tower. We end up figuring out that it ends up being the radius of a circle. You see how this works out here? And that's where I probably put my radio tower, because it would be equidistant to each point, because this would be a radius of the circle. See how that makes it fair? So my circumcenter on an obtuse triangle ends up outside, but they want to know the circle, the vertices of the triangle lie on the circle. You see that one? The longest side of the triangle is the diameter. We see no, this isn't the diameter. The diameter would have gone through it, so no. The circle is drawn inside. No, it's not drawn inside. It's outside. The center of the circle is interior. No, our center is actually outside. Okay. So that's this learning goal about inscribed and circumscribed triangles. Now going back, how can I use my cheat sheet on circles to answer some of these questions? So notice these patterns, A times B, C times D, or adding together my sides. Okay. So let's see. This one is the tip of my cone. Right, is half my snow. So 55 times 2 is 110. My snow is 110. That means the tip of this cone would also have that snow of 110, meaning if you guessed, this would have to be 55. We notice that if we pick this up and translated, it also looks like it would fit right on top. Cool. Now I'm going to do question number 3. Like we said before, these two angles add up to 180. And these two angles add up to 180. So we can use that to set up these equations. Angle Q and angle S have to add up to 180. Okay, so substituting in angle Q is 3x plus 8 and angle S is 5x plus 4. We can set this equal to 180. And we get 21. So that's not our choice, but that's not what we're solving for, right? So we can plug this back in here. We can figure out, well, what is angle R now that we know what 21 is? Because we know angle R and angle P are also 180. So angle R is 6 times x, which is 21, minus 14, plus angle P equals 180. So we can solve for this missing angle. So we get 112 here for angle R, which means if I subtract 112 from both sides, angle P ends up being 180. Take away 112, 68. And that's one of our choices. Well done. All right, let's do this one. We noticed I could take this times this and set it equal to this times this and solve. So let's do that. 5 times x has to equal 2 times the purple one, 3x minus 2. If we distribute, we get 5x equals 6x minus 4. And if we add 4 to both sides, we get x is 4. So we can plug in 4 here, plug in 4 there, and we get 10. Okay, so this distance is 10, and the orange distance is 2, right? So what is the length of KZ? The whole thing would be 2 plus 10, or 12. Well done. 2 plus another 10 makes 12. Now looking at the relationship it makes with the sides. We said the part on the outside equals the whole thing, the part on the outside times the whole thing has to equal the part on the outside times the whole thing. So the part on the outside times the whole thing equals the part on the outside times the whole thing. The part on the outside is 7, and the whole thing is what we're solving for. So we're going to call that x. Okay? So 7 plus x, and then the part on the outside is 11, and the whole thing is 11. The whole line is outside. Now doing a little algebra here. I get it said round to the nearest tenth, so I'll get 10.3. And when I plug that in, that looks about right. This length is 10.3 and another 7, so about 17, and that's 11. I'm looking for a number bigger than 11. Cool. Question number 4. Construct a tangent line that passes through A. What should we do next? All right, this I'm giving you one of my big tips. It's almost always the perpendicular bisector, and I'm going to explain why. Not always, but almost always. What I need to do is I need to cut this in half at a 90. Because what that'll end up doing is it will create the location where I can run my tangent line from, if that makes sense. So my answer is perpendicular bisector. Okay, last one. The part on the outside times the whole thing has to be equal to the part on the outside times the whole thing. So that's just like the other question. It looks slightly different because both are secant lines instead of one being secant and one being tangent. So the part on the outside of the first line is 5, and the whole thing is 5 plus 12. The part on the outside is 4, and the whole thing is 4 plus a. Now, all they want us to do is solve for a, so we'll do that. 5 times 17, 16 plus 4a. When we divide by 4, we get, cool, okay. And that's one of our choices. And so the last step, we're going to just plug that in and see if that makes sense. So I'm looking for a number probably bigger than 12, and I got it. Well done, guys.